Namastey Coders, I hope you are fine. So today is 25th March and we have already solved today's problem of the day. So if you have not solved this problem, you can check out the video. So now it's time to solve the LeetCode 75, and so we have already solved all the first problems of all the topics of LeetCode 75. Now we are on our way to solve the second problems of all the topics, and we have already solved the problems before. One second. Yeah, problem till backtracing, and now it's time to solve the problem of DP1D, right? So if you have not solved the previous problems, so you can check out the previous problems in the video. So let me tell you that this video is a part of LeetCode 75 series, in which we are gonna solve the most important 75 problems from LeetCode, which is most probably come into your interviews. So if you are planning for your placements and trying to practicing the DSA, so these 75 problems will help you a lot. So if you want, you can check out the previous problems. Link is given in the description box. Along with this, we have solved the LeetCode problem of the day, and that video is a part of LeetCode problem of the day series, in which we are gonna solve LeetCode problem of the day daily. And I have uploaded the video, today's video, in my YouTube channel. The link of the playlist is also given in the description box. Along with these two playlist, I have also created a WhatsApp group for the coders, where we can discuss multiple things, our doubts, any problem, and also we can start some good projects. So if you want, you can join the WhatsApp group. The link is given in the description box, and it's completely free. So I suggest you all to join the WhatsApp group. And we have got some pretty good participants in the group. So if you want to be part of a good community, I suggest you all to join the WhatsApp group. So let's start with today's problem, and problem is minimum cost climbing a stair. This problem is from DP, right? 1D, and let me tell you that I will solve this problem in 3 steps. The structure is taken from the interviews. This is the similar way that your interviewer will expect you to solve the problem. So first of all, we will discuss the problem in a very detailed manner, right? We will discuss the inputs, the expected output, and all the technical, all the details which is given to us, right? Then we will try to solve the problem in native approach, brute force approach. Then we will optimize that native approach using the most appropriate optimized solution, right? So the problem is minimum cost climbing a stair. So we are given an integer cost, where cost I is the cost of ith step on staircase. Once you pay the cost, you can either climb 1 step or 2 steps, right? So this is the most important thing. You can either start from index 0 or step with index 1. Okay, return the minimum cost to reach the top of the floor. Okay, so in this problem, what is given is, we have given an array which is the cost of ith step, right? So this is 0, this is 0, 1 and 2 steps. The cost is 10, cost is 15, and the cost is 20, right? And we have to reach the top of the index. Okay, and we can either start from the 0, and we can either start from the first step. And to jump on any step, right, to jump onto the any step, we have to pay the cost. So in this case we will start from this step, 15 step, we will jump, right? And this is the top, so we will jump. So we have to pay only 15 rupees, because we are starting from the 0th in the index. Okay, now in the second case, So the second case, our steps are like 100, then 1, then 1, then 1, then 100, then 1, 1, 100 and 1. Okay, and we have to reach here. So what we can do, we can start from here. So we will pay 1, then we can do 2 jumps, right? We can do either 1 jump or 2 jumps. So we cannot jump on 100th step. So a step with the cost 100, we will jump directly to this step. So this has cost 1, then again we'll pass this step, so we'll jump on this step. This has also 1, so our total cost is currently 3. This is a 100 cost step, so we'll pass this and we'll jump on directly this. Okay, now this is a 100 step, 100 cost step, so we should not jump on this step. So what we'll do, we will jump on this step and then we will pass this step, right? So that our cost will be like 1, and then we'll go to the top. So the total cost is this 1, 2, 3, 4, 5 and 6. So the total cost is 6. Okay, if we do the 2 jumps here, right, and we'll jump on the 100, so that will cost us 105, which is much greater than 6. So that is what we need to do, right? So how can we solve this problem? So what we can do, so this is problem from let's say we can solve this problem using recursion, right? What we can do is, let's say we are at the ith step, and we can ith step, and what we can do, we can check that what is the cost if I jump 1 step and what is the cost if I jump 2 steps, right? We can, right, and what will the minimum cost of jumping, whatsoever will be the minimum, we will take that, right? So let's say this is the steps, we are at this step, right, currently. So we'll, from recursion, what we will do, we can try to jump on this step and we will try to jump on this step, and whatever the cost from these 2 steps, we will take the minimum one and return, adding this the cost of this step. Okay, so the function will be, first of all, the base case is if we are at the top, we will return 0, right? If we are at the top, we will return 0. And if we are not at the top, what we'll do, we will return the cost I okay, plus, so this is the function fx of I, right? So cost of I plus fx I plus 1 and minimum of this I plus 1 I plus 2 plus 2. So whatsoever the minimum of these, we will take that and we will return including the cost of the current step, right? And this is how we'll solve the problem. And what is the time complexity? So at any step we have to choose either between 2, right? The time complexity will be 2 to the power n. Okay, so as you guys are aware about this, if we are using recursion and if we are using repeated steps, right? So let's say we are at 10, right, which is I equals to 0. We have to calculate fi, f1 and f2, and after calculating, and for f1 we have to calculate f2 and f3 and f3. So as we have already calculated f2, we again have to calculate f2 here, right? So that is a repetition. So how to reduce that repetition? How to reduce those steps, right? Because for f2 only we have to calculate f3 f2, f3 and f4, and we have already calculated f3 here. So we don't want to calculate those steps again and again, right? So we can use a memorization here. So we can use DP. So that is a particular concept of a DP, dynamic programming, in which we will store the result. So what we can do, we can store the result of f2, right, f3 whenever we calculate them. And if we calculated them, we can check that if we have the result of f2 or f3 or any f, we can use them directly, right? We don't want to recalculate them at every step. So this is the basic concept of DP. So what we can do, we can make a DP array which is store the result at any point, right, starting from 0 to n-1. And whenever we are at any point, let's say we are at I, right, we'll check that if we have the answer of at I. If we don't have the answer, we'll calculate that, right? So that is the particular concept of DP. So we can solve this problem in just O n time complexity using DP, right? And O n space, because we have to create that DP array of n. So this is the power of DP, right guys? We have solved the problem from 2 to the power n to just O n. So this is a very huge time complexity, and this is just a little time complexity. So you can see that just using a very simple, just using our brain, we can say we have reduced the time complexity from this to this. So this is the power of algorithms, right? Okay, now there is one more optimization we can do. So guys, as you can see, for fx, what we need for calculating fx, we need f. Okay, so let's reverse the problem, right? Let's reverse the problem. So let's say we are at this is the top, right? So what we can say that for reaching top, let's say this is the cost f x minus 1. The cost is fx minus 2, x minus 2, and this is cost f x minus 3, x minus 3, and so on, right? So for reaching top, either we have to pay fx minus 1 or we have to pay fx minus 2, right? So this is not top, this is fx, let's say, right? So fx only depends on fx minus 1 and fx minus 2, fx minus 2. This is not dependent on x minus 3, x minus 4, x minus 5, right? So we can make a formula. Fx is nothing but fx minus 1, fx minus 2, x minus 2, the minimum of those, and plus cost I, cost x, right? So instead of using an array, we can use these two variables only, right? So reduce our space complexity from O(n) to O1. I hope you are with me till here, right? What I'm trying to say is my current state, which is fx, only depend on previous two states, right? It does not depend on any other state. It only depends on previous two states. So we don't need to store the every answer till fx, right? We just need to store the previous two answers. So the x1 is nothing but the fx. So this x1 is nothing but fx minus 1. X2 is nothing but fx minus 2, right? These previous two cost. And what is those cost? The cost at the cost of 0th step and the cost of first step, right? And we can calculate the cost at every step, right? Using just two steps, using the previous two steps. So we will start from third step, the third step, which is I equals to 2. I equals to 0 is the first step, I equals to 1 equals the second step, and I equals to 2 is the third step. So we can calculate the cost of from third step to nth step just using the two variables, which is the cost of third step is the previous the cost of previous two steps plus the cost of I, which is our formula, right? And now what we'll do now for the next step, right? My current cost will also be included in the previous two steps, right? So this is the using. So what is now fx minus 1 for the next step? It is fx, right? Because now fx will become x minus 1 for the next step, right? So my fx will become cost I, and x2 will become x1, right? So fx minus 2 will be replaced by fx minus 1 for the next step, right? So what I'm saying is, let's say I have calculated this cost. I want to calculate this cost. So this is the fx minus 1 and this is the fx minus 2. Now this will become fx minus 1 and this will become so this will become fx minus 2 and this will become fx minus 1. So that is what I am doing here, right? Okay, so that is what 1 second guys. Okay, yeah, so that is what I am doing here. So this is what I am doing here, and at the end, right? So let's say we have reached here. So what we want to do is, the total cost to reach here is either this cost or either this cost. This is fx minus 1, this is fx minus 2. So we will return the minimum of those two costs. So this is the final optimized solution we can using which we can solve the problem. And the time complexity is still on, and the space complexity is now O1. Yeah, give the attention guys, we have reduced our time complexity to O2 to the power n, right? Which is a very disastrous time complexity to On, and we have reduced our space complexity to On till O1. So this is the power of optimization and critical thinking, right? So I hope you have understand this problem well and my solution well. This is all from my side guys in this video, but I suggest you all to, if you have any doubt, right, if you have any doubt in this problem, you can ask me, feel free to ask me in the comment section, or else you can also join the WhatsApp group in which you can ask anything to me, or right? So yeah, this is all from my side in this video. Thank you for your time. Have a nice day.